Hello everybody and welcome to my plate tectonics presentation. My name is Cole Cracklio. If you haven't met me in class already, my name is Cole. You feel free to say hi. Let's hop right into it. So, sorry about that. The plate boundary type I chose was convergent. This is when two plates are going to be moving towards each other. So as you can see on the image here, these plates are both moving towards each other, and it's going to cause one of the plates to be forced under the other one. So right here you can see this oceanic crust is going to be converging with this continental crust. It's going to be being pushed underneath the other one. And the type of stress here is going to be compression stress. With the two moving towards each other, it's going to be compressing and pushing on each other until eventually it's going to pop. We'll get into that later. So the example of this convergent boundary I chose is the Nazca South American plate boundary. It's right on the western edge of South America, right against Chile and Peru. And the Nazca plate is going to be pushed under the South American plate. Those are the two plates that are going to be interacting with each other. You can see the Nazca oceanic plate in this image, which is labeled, being pushed underneath of the South American plate. And the South American plate is going to be moving at about 50 millimeters per year towards the Nazca plate, which does not seem like a lot. It seems pretty slow, but definitely causes issues. So some of the features that are caused by this movement are going to be the Andes Mountains, the Andes Mountain ranges, which you can see on this image on the continental crust. And it's also going to cause the Peru-Chile Trench, which is also called the Atanica Trench. Atanica Trench. And that's where you can visibly see that off the coast right there as well. And that trench is going to be a total depth of 26,460 feet below sea level, which is pretty deep. And that's caused by the subduction of the Nazca under the South American plate. And then because of that subduction, it's also going to cause uplift, which is going to cause the Andes Mountains on the South American plate. And because of this movement also, we're going to have earthquakes and volcanoes on this border. The earthquakes are caused by the stress and the pressure. These two boundaries are moving at each other, and eventually it's going to pop. It's going to release that pressure, and that's what's going to cause those earthquakes. And then it's also going to have volcanoes, because when you are pushing the Nazca boundary underneath the South American, the material is going to melt from that Nazca plate. It's going to keep moving down until it melts, and then that's going to rise up through weak spots in the South American plate. So you will see a lot of volcanoes on the continental crust. These are two good examples of images that represent both of the earthquakes and the volcanoes. So you can see on the border here we have all of these earthquakes. This is logged from the 1900s to present day for the earthquakes on Peru's coast. And then also on this image here to the right, you have all of the active volcanoes and some of the plate tectonics on there. So you can see all those volcanoes up the coast of South America. And that's all caused by this Nazca plate interacting with the South American plate right here at that boundary. Alright, so that's all I have. Here's my works cited. It's been a pleasure. I hope you guys enjoyed. We'll see you in class. Thank you.